Welcome. Now we discuss practical problem 13, Gauss-Seidel method to solve a system of linear equations. And this is an iterative method also, numerical practical. And this is the C programming for the Gauss-Seidel method. Problem 13, write a C program to find the solution of the following system of linear equations by Gauss-Seidel method correct to 5 decimal places. First equation, second equation, third equation, fourth equation, and this D, not E. Actually, this is the E or D. P, not D. And this E. So this is the P. So right here, this is the P. And this, and the program is the P. This is the P. 1.5 to this. So this is the P. 4.10 plus P and so on, x1 plus 1. This P equal to 1.5 plus R by 2. And this is the programming. And this Gauss-Seidel method is same as the Gauss-Jacobi method. And what is the difference between them? And for that, we discuss this method, this iterative method, Gauss-Seidel method. We discuss here for the n equal to 4. That is the coefficient matrix, 4 coefficient matrix. And this is the initial values of x1, x2, x3, x4 as x1 0, x2 0, x3 0, x4 0. And this is the step 1. This is the value of x1 in the step 1. x1 1, that is equal to b1 x1 2 x2 0 x1 3 x3 0 minus x1 4 x4 0. So this 0 0 0 from the initial step x0 0, you may choose this x1 0 equal to 0, x2 equal to 0 equal to 0, x3 0 equal to 0, x4 0 equal to 0 is given by a1. And x21, value of x2 for this step 1 is equal to b2 minus a21 x11 minus a23 x30 minus a24 x40. Carefully note that this x11 coming from the previous x1 in this step 1, so this x1 coming from this, but in the Gauss-Jacobi method, this x1 actually coming from the initial step, that is step 0. So in the Gauss-Jacobi method, this x1 is x10 and x30, x40, that is coming from the initial step. And x31, value of x3 for the step 1 is equal to b3 minus a31 x11. So this x1 coming from this step 1. x21 coming from this step, step 1, but x40 coming from the previous step, initial step. But and x4, value of x4 for this step 1, this b4 minus a41 x11 a minus a42 x21 minus a43 x31. So all these x1, x2, x3 from this step 1, x1 this, x2 this, x3 this. So when we calculate this x4, this x1, x2, x3, we use this x1, x2, x3 from this step, we use these values of this. So similarly, we get x1, 2 for the step 2, this x2, x3, x4 coming from the step 1. But only x1 for the calculating x2, this x1 is coming from the step 2. Use this value because we already get improved value of x1, this already. But improved value, we have not improved value of x3, x4. So this x3, x4 coming from the step 1. And x32 for calculating x32, x1 and x2 coming from this step 2. But x4 coming from the previous step, that is step 1. Similarly, x4 for this step 2, this x1, x2, x3, all variables coming from this step 2. So compactly we write this xi for the step r plus 1, equal to 1 by aii bracket bi minus summation j equal to 1 to 4 when I greater than j aij xj r plus 1. When I is greater than j, when I is greater than j, we use this xj from this step r plus 1. But when I is less than j, we use xj from the previous step, the rth step. So when I is greater than j, this here 1 2. So I is less than j. So this I is less than j. So we use this x2 from the previous step 1. But here this a to 1, here I is greater than j. So I is greater than j. We use x1 from this step 2, r plus 1 step. And in this equation this x31, this I is greater than j, so I is greater than j, we use x1 from the r plus 1 step, that is second step. In this step 2, use the x1 from the step 2, and this 3 a32, I is greater than j, 3 is greater than 2, so we use x2 from the step 2, there's r plus 1 step here. But the in this A34, I is less than j, I is less than j. So x4 coming from the previous step, that is R step, that is x4 from the step 1. And the stopping criteria similar to the Gauss-Jacobi methods. This modulus value of xi r plus 1 at step minus xi from the r step. This less than equal to tolerance level. And the condition of convergence same as to the Gauss-Jacobi method. This is the diagonal dominant coefficient matrix. Actually, this is the condition, important condition. This condition is sufficient condition for convergence of this method, but not necessary. And the coefficient matrix is strictly diagonal dominant, then the Gauss-Seidel method converges. But if the Gauss-Seidel method converges, then in coefficient matrix A may not be strictly diagonally dominant. Come to the problem. This is the float variable a 10 10 b 10 x 10 y 10 error term. This 1.0 10 to the power minus 6 integer variable n I j step and flag variables. We may omit this from slash start to star slash, and individually you input these values a11 a12 and a1 a44 b1 b2 b3 b4 from this. And this step 0, this is the step 0 initial step. Xi equal to 0, we here choose the initial value of this the initial value of initial values of x, and this now calculation in this step. Wording this, first check the in and then type the following two printf lines, this printf line and this printf line, because we here n equal to 4. So here we write this up to x1 x2 x3 x4. If n equal to 5, then you must write this x1 x2 x3 x4 x5 and so on. This flag equal to 0, this I equal to 1, I less than equal to n I plus plus, y I equal to bi. So initially I equal to 1, so y1 equal to b1, j equal to 1 up to j less than equal to n j plus plus. If I greater than j, if I greater than j, from this compact notation I greater than j, we use xj from the present state, values of xj. So here the value of yj, this is the yj, this is the equal to 1 and y equal to 1, I equal to 1 y equal to 1. Here I equals j, so we omit this this if and this if. Again for j equal to 2, again for j equal to 2, this I equal to 1 j equal to 2. So come to this loop, this if I less than j, I less than j, I equal to 1 j equal to 2. So y1 equal to y1, old y1, that is the b1, this is the b1 minus a1j, a1j. So a12, this is the value of a12, and this is the x2. X2 is the initial value. X2 is the initial value. This x2, this is the x2 equal to 0. And again j equal to 3. So I equal to 1, j equal to 3. I equal to 1, j equal to 3. So this loop, if this if loop, if loop I less than 2, I equal to 1, j equal to 3. So y1 equal to previous y1 minus a13, this a13, and x3. This is the initial value of x3. This, and j equal to 4. So I equal to 1, j equal to 4. From this if logic, the if loop, this y1 equal to previous y1 minus a14 into x4. Then come to the I equal to 2. So we get y1 equal to the, this actually this x1 is the y1. This improve this y1, that is the y1 equal to y1 by a11. This is the a11, this is by a11. And next I equal to 2, I equal to 2 for the second equation. So after completing this I equal to 2, this loop j equal to 1 to 4, you get the value of x2. This is the value of x2, value of x2 for the step 1. And this I equal to 2, I equal to 3, I equal to 4. When I equal to 4, you get from the fourth equation, from this j equal to this. Now we check these consecutive values of this tolerance level. Absolute value of xi minus yi, actually xi minus yi. This xi is the previous value. This x0, x1 equal to 0, x2 equal to 0, x3 equal to 0, x4 equal to 0. And this the calculated value yi is greater than error term, then flag equal to 1. And this flag, when flag equal to 1, we again enter in the do loops. We compile this do loop again. Now this xi equal to yi. So after this xi, that is x1 equal to this calculated value of y1, x2 equal to this calculated value of y2, x3 equal to y3, x4 equal to y4. And this increment of the step, the step uh, 1, 0 plus 1, that is the step 1. Step 1. It's entered the step 1. And similar this yi equal to b1, this is the b1, and this y1, y2, y3 for this, and we calculate this way. And this is the solution of this I equal to 1 to I less than equal to n, I plus plus. This is the percent up to 5 decimal places. So correct this question up to 5 decimal places, up to 5. Up to 5D, and this is the p equal to 1.5 r by 2, p 1.5 r by 2, and this is the check this. And all C programming file and all PDF file of this explanation are given in the description box. And we first save this and and compile and run this. Put here are equal to 5 last digit of your roll number, enter. And this is the solution of this x1, x2, x3, x4. Solution of the x1, x2, x3, x4. You must check these values yeah, from the system of equation, given system of equation, and check this whether it satisfied or not. And thank you for watching this video.